Okay, so this is the last of the transformations, dilations. And we saw from the video that we took a point or a set of points and we multiplied it by a factor. And so the new point was kx, ky. And we saw this was different than the previous three transformations because the size changed. So hence, that was the point we were studying similar triangles, all that. That was the connection dilations. And so what we saw is that, it's not an isometry, but all the angle measurements were preserved. So this was similar triangles, similar versus congruent, which is fine. And then we saw how in the video. Okay, let's take a look at dilations on GeoGebra. So what we're going to do is we're going to input we're going to input 0, 0, and we're going to input the point 1, 4. So the first thing is that dilation affects the distance. We're going to, in this class, the center is going to be the origin. So the idea is that dilation affects the distance. So what we're going to do is we're going to dilate the points. So let's go to circle star and transform. We need more transformation. So let me X out of this. We need more. Go back to construction, transform. We're going to dilate from the center point. So B from A, let's do by a factor of 3. Okay, and then if we shrink it down, we see that B prime there. And if we go back to the calculator, we can see that 1, 4 by a factor of 3 went to 312. So and the idea is that it multiplies the coordinates. Well, what else is going on with the dilation? Well, let's take a look at the distances of AB versus AB prime. So let's go back to circle star and let's go to measure, right? So we want to measure the distance. So first of all, I want to see the distance of AB versus the measurement of AB prime. And you can see that the distance is multiplied by a factor of 3. Okay, so that's the first part of dilation. Now let's see the effect that dilation has on polygons. So what I'm going to do is I'm going to delete this. Let's take that out. Okay, and let's input some other points. So what I want to do is I have 1, 4. I have the point 1, 1, and I have the point 5, 1. Okay, and what I'm going to do is, well, let me take that distance out. Now, I want to make this into a polygon. So go back to circle, triangle. Scroll down, let's see, lines, polygons, and just click on the 3 points, B to C, C to D, B back to D. So we have a polygon here, and the idea is we have the coordinates. We can, let's see, let's go back to move, take that out of there. Let's highlight the 3 points. I just want to see the coordinates. So let's go to highlight it into 3 dots, settings. I want to see, let's see, show label. Just show the value. And we see that the coordinate shows up there. Let's do it, that's D, 3 points, settings, show label. Just show the value, X, and then go back to C also. 3 dots, settings, and let's see, I want the value, X. Now what I want to do is we can also see right here in the calculator part the different segments. So we have a right triangle. We have segment B is 4, we have segment D, which is 3, and segment 5, which is segment C, which is 5. The other thing that GeoGebra gives us is this T1 actually gives us the area of the polygon. So this is something else we're interested in. So let's go back to circle triangle. I'm going to move this weight in the corner. Put this in the corner. Now this is kind of cool. So go back to calculator, and we're going to input the slider K. Okay. Then we're going to go to 3 dots, settings, slider. Now just enter the number 0 here, and then move the mouse on. Do not hit tab, do not hit enter. Let's put it up to 10. And then we can see the slider has changed, and X out of that. Okay, the next thing I want to do is I want to dilate this entire polygon by any factor I want. So let's go back to circle triangle, go back to transformations, and we need some more, so let's go back to more. Let's see, transformations. We want to dilate. So I want to dilate the triangle from the origin, and we're going to put in K because that was our slider. Okay, and let's shrink this down because let's see what's going on here. Whoops. Move. Let's move this corner. You'll see this is kind of cool. Let's go to the calculator, and let's find our slider. Okay, ready? Let's see what happens. So we see that it's increasing in size. So let's bring it all the way to 10. Let's see what's going on here. Well, the coordinates, let's see, 1, 1, 1 to 10, 10. 1, 4, 1 to 10, 40. And 5, 1 went to 50, 20. What else happened? Let's see. Let's see what happened to the distance. Well, let's see, B, C, and D were 5, 4, and 3. What happened to the lengths? They got multiplied by 10, 40, 50, and 30. The last thing is, what happened to the area when we dilated by a factor of 10? Well, the original area was 6, but now the new area is 600. And that kind of makes sense because each of the dimensions got multiplied by 10, so that means the total area gets multiplied by 100. So that is the visual of dilation, and let's just get to the nuts and bolts. Nice. The one thing I forgot to talk about with dilation is that these are similar figure, which means the angles measurements are preserved. So we can clearly see that the right angle is preserved. Let's just take a look at the other angle. So let's go to circle triangle. And we're going to measure the angle. So let's do, what is this? I'm going to show you the names. And then, so that's 53 degrees. And let's do the same thing here. Also 53 degrees. Let's check out the angle down here. I believe this is D. I could be wrong. That's 36 degrees. Nice. And so the idea is that dilation creates similar triangles. So the lengths, they're in proportion to each other, and the angle measurements are preserved. Good. How, the lengths, so the perimeter got multiplied by K, and we saw the area got multiplied by K squared. But then as we got more, so what else did I want to say? The area multiplied by K. We saw that when K was greater than 1, we had an enlargement. And we saw when K was between 0 and 1, this is a shrink. We saw this triangle got really small. Then that makes sense because the number is 1/2 of X, 1/2 of Y. This is like a shrink. Or what's the word the book uses? Reduction. The book uses the word reduction. Some of you might be asking, well, what happens if the K was negative? Which, in the computer, if K is negative, what's going on? Well, it's still enlargement and shrink, but let's think about this. For example, let's take X, Y, and map it with a dilation of -2. So we have negative 2x, negative 2y. What we want to see this as, we actually want to see this as two, we're going to represent, d of negative 2 as actually, first, a dilation of 2. So we have x, sorry. So the first thing we're going to view this as is a dilation of 2. So xy gets mapped to 2x, 2y. And then the negative 2, actually we're going to see it as a rotation of 180 degrees. So 2x, 2y becomes, if you remember from your rotation rules, negative 2x, negative 2y. So we generally keep the dilation positive, and then we throw on like a rotation of 180 degrees. So that's what's going on. So once again, that's the idea. So in the book, you're just going to see the dilations positive. Maybe they'll add on a rotation of 180. The other thing is that as we got a little more involved in the video, we noticed that this dilation factor of k meant that the distance from the point to the center increased by a factor of k. Well, in this class, we're keeping the center at 0. So once again, you recall initially, we started like 1, 4. And we kept the center 0, 0. So like this distance, well, let me make this 1, 3. No, 1, 4 is fine, whatever. So 1, 4, we saw the distance was, this is radical 17. But when we multiplied it by a factor of 10, when we dilated by a factor of 10, the new point was, 1040. And what we saw is that the new distance was actually 10 radical 17. And so that was the idea that the dilation affected the distances from the center. In this class, the center is always the origin. So that's basically it. What else did I want to say? Also, when they talk about the scale factor, let's see, 0, yeah. When they talk about the scale factor, so the question is, like, where did the 10 come from? Where did the 2 come from? Well, the ratio is, it's the length of so it'd be like, it'd be the length of the image over the length of the pre-image. So for example, they would say, 1, 4 was dilated to 1040. What was the scale factor? So you'd say, okay, well, the final image was 10 divided 10 radical 17. And the pre-image distance was radical 17, so the answer is 10. And so it was dilated by a factor of 10. And those are the exercises in the book you'll be doing. That's basically it for for dilations. So I'll give you some problems in the book to do. Good.